Hello, everyone. Today, we're going to cover Chapter 6, Part C. We're going to talk about several tools we can use to detect quality problems. We'll talk about check sheets, scatter diagrams, cause and effect diagrams, histograms or bar charts, Pareto charts, and flow charts. First of all, check sheets. A check sheet is any kind of form that's designed to record data. For example, Mary Beth, the manager of an apartment complex, feels overwhelmed by the number of complaints she's receiving. Below is the check sheet she has kept for the past 4 weeks. So here we have the categories for complaints: parking, pool, tenant issues, electrical, plumbing. Every week, she's recording how many complaints she's receiving in each of the categories. So by looking at these check sheets, can you identify the area that needs to be improved? Yes, parking, right? Because you can see you're getting more and more complaints over the time. The next one is scatter diagram. A scatter diagram is a plot of two variables showing whether they are related or not. On the x-axis, we have the independent variable, and the independent variable affects the y value. On the y-axis, we have the dependent variable. The y value depends on the x value. For example, suppose you're working as a head nurse at a hospital and you are managing all the nurses in this hospital. Recently, you are getting more and more complaints from your patients. Why are you getting more complaints? You notice that recently, more nurses are absent than usual, and you think this could be one of the reasons. So you want to see if there is any relationship between the number of nurses absent and the number of complaints per day. So you want to create a scatter diagram. Which one should be on the x-axis and which one should be on the y-axis? Remember, y depends on x. The number of complaints depends on the number of nurses absent. So the y-axis should be the number of complaints, and the x-axis should be the number of nurses. After you plot the scatter diagram, you can use it to find the relationship between x and y. For example, if your scatter diagram shows this trend that's going up, that means there is a positive relationship between x and y. In other words, x and y move in the same direction. If one goes up, the other goes up. If one goes down, the other goes down. Let's look at another pattern. If your scatter diagram shows this trend that's going down, there's a negative relationship between x and y. In other words, x and y move in the opposite direction. If one goes up, the other goes down. If one goes down, the other goes up. Next, let's look at another pattern. If your scatter diagram shows a horizontal trend and the data points are all over the place, then there's no apparent relationship between x and y. Because even if y stays in the same value, the x values can take different values. Okay. Now let's try this example. Boston Electric Generators has been getting many complaints from its major customer, Home Station, about the quality of its shipments of home generators. Daniel Smith, the plant manager, decides to collect information on defective shipments through a form she has asked his drivers to complete on arrival of customer stores. The forms for the first 279 shipments have been turned in. Develop a scatter diagram. What would you recommend to reduce the percentage of shipments with defects? So in the first week, they shipped out 23 shipments, and of these 23 shipments, 5 shipments contained defects. So the percentage of shipments with defects is the 5 over 23, which is 22%. And you collected, you suspect that this percentage is related to the turnover. So you collected the number of new hires, the number of terminations, and you calculated the turnover, which is the number of new hires plus terminations. In the first week, you hired 1 person, and you had 0 terminations. So the turnover is 1 plus 0, which is 1. And you repeated this every week, right? In the second week, you computed the percentage of shipments with defects, and you also computed the turnover. And you want to create a scatter diagram. You believe that the percentage of shipments with defects is related to turnover, and to find the relationship between the 2 variables, you want to create a scatter diagram. So which one should be on the x-axis and which one should be on the y-axis? So this percentage depends on the turnover. So this should be y and this should be x, right? So in this xy plane, the turnover, when the turnover was 1, the percentage of shipments with defects was 22. So it's 1 and 22. And 3 and 23. 3 and 23. And 5 and 25. 5 and 25. And 6 and 30. It's 6 and 30. So can you find the relationship between the 2? It looks like there is a positive relationship between the 2. So if the turnover goes up, the percentage of shipments with defects goes up. When the turnover goes down, the percentage of shipments with defects goes down. So what would you recommend to reduce the percentage of shipments with defects? We need to reduce the turnover. The answer is reduce the turnover. Okay, so this is an exercise problem. Now let's go to the cause and effect diagrams. The cause and effect diagram is also called the fishbone diagram. And it's a diagram that relates a performance problem to its potential causes. This is a typical structure of the cause and effect diagram. It looks like a fish. On the head of the fish, you're going to put the problem we have, and then you're going to draw the backbone of your fish, and you're going to group the causes into 4 categories. Materials. Is the problem caused by the materials we use? Methods. Is the problem caused by one of the methods we use? Manpower. Is the problem caused by our employees? Or machinery? Is the problem caused by the equipment we use? And these groups are called 4Ms. So let's take an example. The operations manager for Checkerboard Airlines at Port Columbus International Airport noticed an increase in the number of delayed flight departures. Draw a fishbone diagram to determine the root cause of the problem of delayed flight departures. So on the head of the fish, you're going to put the problem we have, which is the delayed flight departures. And then this is the backbone. And we're going to list all the potential causes. Materials. Is the problem caused by late baggage to aircraft, or late fuel, late food service, or methods? Delayed check-in procedure, or waiting for late passengers, or manpower, late cabin cleaners, or late cabin crew, or machinery, mechanical failures. Now the next one is histograms and bar charts. Histograms are also called bar charts, and let's take an example. The manager of a neighborhood restaurant is concerned about the smaller number of customers patronizing his eatery. Complaints have been rising, and he would like to find out what issues to address and present the findings in a way his employees can understand. The manager surveyed his customers over several weeks and collected the following data. On the first column, he listed all the complaints, and in the second column, he counted how many times he received complaints in each of these categories. So how can we draw the histogram of this data set? On the x-axis, we are going to list all the complaints. The first one, discourteous server, slow service, cold dinner, cramped tables, atmosphere. On the y-axis, you're going to put the frequency. And on each category, you're going to draw a bar, and the length of each bar represents the frequency. So the first bar goes up to 12. Right? This is 10, 20, 30, 40. The first one goes up to 12. And the second one goes up to 42. And the third one goes up to 5. And next one up to 20. And the last one up to 10. Now the next one is something called the Pareto chart. Pareto was an Italian economist, and he studied the way money is distributed among people. He realized that not everyone is as rich as the others. So he drew the following graph. On the x-axis, he listed all the people from the richest person to the poorest person. So this is the richest guy, this is the second richest guy, and so on. On the y-axis, he put the cumulative wealth. Cumulative wealth. So for the first guy, this is the wealth of the richest person. But for the second guy, this is the wealth of the richest person and plus the wealth of the second richest person. So this is the cumulative wealth. So we keep doing this for all the people in the world, and we'll get a graph like this. The richest guy, second richest guy, and so on. So at the beginning, the graph goes up very fast, and then it slows down. This is called the Pareto chart. So what he discovered is that a significant portion of the total wealth is owned by a small number of people. In fact, he found out that only 20% of people own 80% of the total wealth. This is called the 20-80 rule. And also, 50% of the people own 95% of the total wealth. Now, we can apply this idea to many areas. Let's say I'm working as a waitress in a restaurant. I receive many complaints from my customers. And according to the Pareto's idea, most of the complaints come from a small number of areas. And by improving these areas, I can get rid of most of the complaints. And also, let's say I'm producing laptops in the production line. Some of the laptops are defective. And according to this idea, most of these defective items come from a small number of reasons. By finding out these reasons and by fixing them, we can get rid of most of the defective items. And let's take another example. Let's say you're running a Walmart store. You have hundreds of items on the shelf. And since you have so many items in the store, you don't know which items to monitor more closely. According to the idea, most of the profit I make come from a small number of items. I don't need to spend all of my time to monitor all of my inventory. I can focus on these items that generate most of my profits, and I can use my time more efficiently by focusing on those items. So the Pareto chart can be summarized as follows. The 30-80-20 rule says 80% of the defects come from 20% of the causes. And by concentrating on the 20% of the causes, managers can attack 80% of the problems. So let's take an example and see how we can construct the Pareto chart. The manager of a neighborhood restaurant is concerned about the small number of customers patronizing his eatery. Complaints have been rising, and he would like to find out what issues to address and present the findings in a way his employees can understand. The manager surveyed his customers over several weeks and collected the following data. Draw the Pareto chart. Which area should the manager focus on to get rid of 80% of the complaints? So here we have the list of complaints and the frequency. And to construct the Pareto chart, we need to follow some steps. Number one, sort the complaints from the highest frequency to the lowest frequency. Number two, compute the percentage frequency. Number three, compute the cumulative percent frequency. Number four, plot the cumulative percent frequency against the complaints. So the first one is sort the complaints from the highest frequency to the lowest frequency. So if you look at the frequency, which one is the highest? This one, slow service. So put this on top, slow service, 42. Now, which one is has the second highest frequency? Prompt tables, 20. Prompt tables, 20. Next, discourteous server, 12. Atmosphere, 10. Cold dinner, 5. Now we need to find the percent frequency and cumulative percent frequency. To find the percent frequency, first we need to find the total. So you add all the frequencies, add them up, you get 89. Now to compute the percent frequency, you need to take the frequency, which is 42, and divide it by the total, 89 times 100, because we wanna make it a percentage, and that's 47.2%. And repeat this for the rest of the items. Take the frequency, 20 over the total times 100, that's 22.5%. Next, 12.89 times 100, 13.5. 10 over 89 times 100, 11.2. 5 over 89 times 100, 5.6. And next, we need to compute the cumulative percent frequency. Cumulative percent frequency means we need to add all the percent frequencies up to the current category. So for the first category, cumulative percent frequency is the same as the percent frequency, because this is the first one. But for the second category, the cumulative percent frequency is the sum of the percent frequency of the previous one and the current one. So it's 47.2 plus 22.5, which is 69.7. For the third one, the cumulative percent frequency is the sum of all these three. 47.2 plus 22.5 plus 13.5 equals 83.2. For the next one, add all these four frequencies, you get 94.3. For the last one, you add all the frequencies, you get 99.9%. Actually, this should be 100%, but I think this is a rounding error. So using this, how can we draw the Pareto chart? We're going to draw the x-axis and the y-axis. On the x-axis, you're going to put the list from the highest frequency to the lowest frequency. So the highest frequency is slow service. The next highest frequency is cramped tables, discourteous server, atmosphere, and cold dinner. And on the y-axis, you're going to put the cumulative percentage frequency. Right? What's the cumulative percent frequency of slow service? It's 47.2. Okay, so this is 50%. This is 100%. 47.2. The second one, the cumulative percent frequency is 69.7, almost 70. For the next one, it's 83.2. Next one, 94. Next one, 99.9. Okay, so now you connect the dots. First, you start from the origin, and then connect the dots with the line segment. Now this is the Pareto chart. Okay, this is the Pareto chart. Okay. Now the last one is the flow chart. Flow charts graphically represent a process using boxes and interconnected lines. So let's see what kinds of shapes we can use. A terminator means the start or the end of the process. An ellipse is used. We're going to use an ellipse. An operation is an action plan. A rectangle is used. A decision node is a question. We're going to use a diamond. A wait node represents a delay or inventory of goods. A triangle is used. A flow shows movement of customers, goods, or information. An arrow is used. Okay. So let's take an example and see how we can draw the flow chart. Arnold Palmer Hospital wants to make MRI service efficient for patients, doctors, and the hospital. The first step is to develop a flow chart for this process. A staff observed a number of patients and followed them from start to end. here are the 11 steps. Number 1, physician schedules MRI after examining patients. So that's the start step. So we're going to use on the lips. Start. Let's call it number 1. Number 2, patient is taken from the examination room to MRI with test order and a copy of medical records. Now, this is an action step, so I'm going to use a rectangle, number 2. Number 3, patient signs in, completes paperwork. This is another action step. Number 3, patient is prepped by physician for scan, another action plan. Technicians carries out the MRI scan, another operation. Technician inspects film for clarity, number 6. Now, number 7, if MRI is not satisfactory, which happens 20% of the time, steps 5 and 6 are repeated. So here is a question, right? This is a decision node. We need to decide if the MRI is satisfactory or not, right? So for a decision node, we're using a diamond, right? This is 7. If it's not satisfactory, we need to go back to number 5 and repeat 5 and 6. And this happens 20% of the time. Otherwise, we move forward. 80% of the time, we move forward. And then patient is taken back to the hospital room, and at the same time, MRI is read by radiologist and report is prepared. So number 7, 8, and 9 are performed at the same time, right? So we're going to connect them in parallel, 8 and 9. And number 10, MRI and report are transferred to physician. Okay, that's followed by 9. And then finally, patient and physician discuss the report. It's the end, right? So after this, we have number 11. So this is the completed flow chart. Okay, this is everything we have today. I'll see you next time.